Okay, question 3, which, even if you don't want to do this question, I'm going to force you to do it. It's all about force. Right. Given that two forces of magnitudes 8 and 12 are perpendicular to each other, find the angle between the resultant and the 12 Newton force, the magnitude of the resultant. Well, this is lovely, isn't it? Because this is just a kind of beginning all this stuff sort of question. So for part 1, we've got a little diagram where we have the 12 Newton force, the 8 Newton force. We're told they're perpendicular. There would be a resultant force. There it is. That was meant to be a straight line. Oh, that says R. That says 12. Just noticed that we have some issues with the way that things have come out there. And we're looking for the angle that the resultant makes between the angle and the 12 Newton force. So we're looking for this angle here, aren't we? And so we've got a lovely little right-angled triangle where, you know, we've got a distance of 12 and a distance of 8. And so we're going to do our calculations with that. So what would we say? Tan theta, because that's the opposite, that's a right angle, isn't it? So tan theta is opposite over adjacent. And we do inverse tan on our calculator in degrees of 8 over 12 and get 33.7 degrees to 3 significant figures, 33.6900. Brilliant. And then it says find the magnitude of the resultant as well. And so we're going to use Pythagoras Theorem to calculate the magnitude of the resultant. R squared is 8 squared plus 12 squared, which gives us 64 plus 144. I'm embarrassed to say I'm just doing this on the calculator. I don't really need to. 208. And so we do the square root of that. And well, it's 14.4 newtons again to 3 significant figures. Did they? I would have thought they probably accepted. Yeah, they accepted 4 root 13, which is the simplified third form, but they didn't accept root 208. But actually, we know in mechanics, you'd want to give your answer to 3 significant figures, so I think we'd know to give 14.4 as our answer. Great, lovely little introduction to resultant forces in that question. But then, it's given instead that the resultant of the two forces has magnitude R and acts in a direction perpendicular to the 8 Newton force. Calculate the angle between the resultant and the 12 Newton force. Okay, so we're now wanting to do this slightly differently. So we've got a new diagram for part 2. Well, that's 8. That's 12. Here's our resultant, which I've read before, so I'll do it red again. Let's call this angle, should we call this angle alpha now, so that we're talking about something different. Okay, so actually we need to think about how we can work this one through. Well, let's see how we can work this out. What do we know? If we're thinking about a horizontal component, let's work a few things out with this. So horizontally, the only force that we have in that direction is 12 cos alpha. Okay, so that is the horizontal component of our resultant force. So actually, that's what R is equal to, isn't it? R must be equal to cos alpha. Because 8 doesn't contribute anything in that direction. So So that's a start. What were we asked for? The angle between it and the 12 Newton force, right. If we think about vertical motion, then actually what we can see from our diagram is if R is a horizontal force, then the resultant force in the vertical direction is 0. R has no component in the vertical direction. So we can deduce from that that 12 sine alpha is equal to 8. And actually this is the crucial equation, isn't it? Because this gives us our key into finding alpha. That means that sine alpha is equal to 8 over 12 this time. And we're left doing inverse sine of 8 over 12. Which gives us an angle of 41.8. Again, that is recorded to 3 significant figures. Now remember this, I'm going to use this angle in a moment, so I'm going to store that in my calculator to make sure I use the full version of it. So I stored it in memory A on my calculator. And now I can go back to the resultant force. We did it in slightly the wrong order, but we've said that R is 12 cos alpha and 12 cos alpha will be 12 times the cosine of the angle that we just found, which is 8.94 newtons. Again, that's a figure given to 3 significant figures. And there we go. That was another load of marks. It's going well. Okay, we happy? And that's maths.